Alright, so let's take a look at number 8. It says bridge is 270 feet tall and can move up or down by as much as 10 feet. So 270 feet tall, and then it can move up or down. So it can move up or down by as much as 10 feet. And you know, you think, well, what are you talking about, a bridge moving up or down? Well, the type of movement we're talking about is movement that would be caused by weather or traffic, earthquake, that sort of thing. So if you take a look at the bridge, you see how the bridge, as the traffic is passing, that it kind of dips down a little bit. So there's a little bend in it. The reason for that is that if it were stiff, if it were rigid, it just would snap. So to be able to take into consideration weather events like earthquakes, and then just normal everyday traffic, these things are built with a little bit of bend in them. So what we're trying to say there is that we're trying to say if it's 270 feet tall and it goes up or down by as much as 10 feet, what would the maximum and what would the minimum heights be? So the maximum and minimum heights. Well, part of that you could probably just figure out. You know, 10 feet above 270 would be 280. 10 feet below 270 would be 260. But what we want to do here is we want to set up an absolute value equation. So let's take h. So h is going to represent the height of the bridge, and it's going to represent the actual height. And what I mean by actual is that because it fluctuates, maybe it goes up, maybe it goes down. It should be 270, but the actual height may vary depending upon traffic and weather and all those kinds of conditions. Now, what it's supposed to be is not the difference between what it is versus what it should be. Shouldn't be any more than 10. So that's why we're going to say equal to 10. All right, now, so this idea of absolute value, by the way, let's just make sure we're kind of clear on that. Absolute value is the distance away from 0, and distance is always a positive number. The reason for that, right, so we could say distance is always positive, or at least we measure it that way. You know, nobody lives negative 3 miles away from school. You can't drive your car negative 60 miles an hour. So there's certain situations where negative numbers just don't make sense. So it doesn't really matter the direction, whether you're coming from the positive side or you're coming from the negative side. Regardless of which direction you're coming, we measure that distance in terms of a positive number. So it doesn't matter if the bridge is bending up or it's bending down. The distance that it moves is going to be a positive number. So to account for the fact that there's two different kind of bends, we have, well, maybe it's coming from the positive side, right? That's kind of the bending up. And so what happens here is that we're just going to keep the equation the same. So exactly as I see it, that's how I'm going to solve it. H minus 270 equals 10. If I add 270 to both sides, I get H equals 280. Right, and we predicted that 270 plus 10 would give you 280. So that's the bridge kind of moving up. The other thing is, what if it moves down? So think of that as kind of, well, what if it's coming from the negative side? Because we're trying to measure the distance from where it is to where it should be. So if I look at the other side here, this is going to be our negative case, and what we're going to do is we're going to switch the sign. Because we're going to say, well, what if it's coming from this other direction? So I have everything the same. H minus 270 equals, the only difference is that this is now going to be a negative 10, whereas this one stayed the same, and it was a positive 10. Right, just doing that in the two different colors there, so you can kind of see what stayed the same and what changed. And then from there, I'm just going to add 270 to both sides. So plus 270, and then subtract, right signs are different, so subtract, keep the sign of the bigger, so we get 260. So our minimum height here would be 260, and our maximum height would be 280. And I'm just using min as a shortcut for minimum, and max a shortcut for maximum. Alright, so go ahead and pause now and try 8.2 and 8.3. Alright, so let's take a look at 8.2. Should have got h equals 230 and h equals 270, and then for 8.3 should have got h equals 185 and h equals 215. Alright, so that finishes up problem number 8.